Ever watched a robot juggle objects or navigate a cluttered room? It's pretty impressive, right? But here's the secret. Making robots move smoothly in unpredictable environments isn't just tricky, it's a huge challenge. Today, we're diving into a game-changing approach called Re4MPC, which could make robots smarter, faster, and way more adaptable. Let's break it down. So motion planning is like a robot's brain, figuring out the best way to move from point A to point B. But traditional methods, they're like using a calculator to solve a puzzle, slow, rigid, and not great for real-world chaos. Imagine a robot trying to walk on uneven ground or dodge a moving object. It needs to adapt instantly, but older systems struggle. Enter Nonlinear Model Predictive Control, NMPC, a robot's superpower that predicts future movements and adjusts in real time. But here's the catch. NMPC needs a model of the robot's physics. If it's too simple, it can't handle complex tasks. If it's too detailed, it's slow and computationally heavy. That's where Re4MPC steps in. Think of it as a robot's adaptive framework. It reactively switches between different models, costs, and constraints depending on the situation. Like a chef using different tools for different dishes, sometimes a simple recipe, sometimes a detailed one. How does it work? Re4MPC uses deep reinforcement learning, DRL, a type of AI that learns by trial and error. The robot trains in a simulated environment, learning when to use which model. For example, it might try thousands of ways to move, getting rewards for successful paths and penalties for collisions. Over time, it figures out the optimal strategy. The magic happens in two parts. 1. The DRL Policy, the robot's decision-maker, choosing the best model, cost function, and constraints for the current situation. 2. The NMPC Module. Once the DRL picks a model, this part crunches the numbers to generate smooth, safe trajectories. The results? Re4MPC outperforms traditional NMPC by a lot. In tests with a mobile manipulator, a robot with a mobile base and arm, it reached goals faster and with fewer computational hiccups. Plus, it's open source, so researchers everywhere can build on this work. So why does this matter? As robots become more integrated into our lives, think warehouse pickers, search and rescue bots, or even household helpers, we need them to be smarter, faster, and more adaptable. Re4MPC is a big step toward that future. Next time you see a robot in action, remember, behind the scenes, it's probably using some version of this kind of tech. Thanks for watching. If you like this, hit subscribe and let me know in the comments what robot tech you're most excited about. Stay curious.